All right, using solution C for example 1 as a model, determine the factors of x cubed plus b cubed. All right, solution C did something like this. All right, let's start. Let's let f of x equal x cubed plus b cubed. Now let's start substituting in values of x that would make this equal to 0. I choose negative b. All right, so if I have negative b cubed plus b cubed, well, that equals 0, obviously. Now hopefully you realize that b can be pretty much anything. If b is 5, well then what I just did is so let's say we have x cubed plus 5 cubed. I'm just going to let x equal negative 5, and then you've got, this is negative 5 cubed plus 5 cubed. Well, that's going to be 0. If b was 9, so if they gave me the problem solve, or factor x cubed plus 9 cubed, let's say, well, I just find f of 9, or sorry, f of negative 9. Negative 9 cubed plus 9 cubed would just be 0. So we're just saying that if you have x cubed plus some number cubed, then one of the zeros is just when x is the negative of that number, obviously. All right, so we know that x plus b must be a factor, right? Because if negative b makes this expression equal 0, then when you let x be negative b, we know that one of the factors is going to be x plus b, because negative b plus b equals 0. All right, let's do our long division to see what the other factor will be. All right, we take x cubed and we divide by x, and that gives us x squared. Now we take x squared and multiply by x plus b. That gives us x cubed plus bx. Subtract x cubed minus x cubed, 0. 0x squared minus bx squared, negative bx squared. Negative bx squared divided by x is negative bx. Now we're going to multiply by x plus b. That gives us negative bx squared minus b squared x. Now we subtract negative bx squared minus negative bx squared is 0. 0x minus negative b squared x is b squared x. Next we take our b squared x and divide by x, and we get plus b squared. Now you take your b squared, multiply by x plus b. That gives us b squared x plus b cubed. And we do our subtraction. Bx squared minus bx squared, well, that's nothing. B cubed minus b cubed, and that is 0, and there are 0 remaining. So when we divide x cubed plus b cubed by x plus b, we get x squared minus bx plus b squared. Same thing over here. We divided x cubed plus 125, which is 5 cubed, by x plus 5, and we got x squared minus 5x plus 25. And x cubed plus 729 divided by x plus 9 is x squared minus 9x plus 81. Now we're hoping you notice that when you had a 5 cubed here and an x cubed here, we ended up with an x squared and a 5 squared, an x squared and a 9 squared for when x cubed and 9 cubed, with a minus 9 times x, 9 and x, minus 5 times x, 5 and x, minus b times x, b and x. All right, now we know there's x plus b is a factor, but also the other factor is x squared minus bx plus b squared. So a lot of people like to memorize this, and that's totally fine. If you ever have a perfect cube and another perfect cube and they're being added together, you can easily factor it just by taking, add the two numbers together that were being cubed, and then in the other bracket you square the two numbers that are being cubed, here and here, and in the middle you do minus the two numbers. All right, so here it's x being cubed and 5 being cubed, and so you have an x and a 5. In the middle you have minus 5 times x. On the left you have x squared, and on the right you have 5 squared. Over here you've got x and 9 that are being cubed and added together, so the sum of cubes. Over here you just take x and 9 and you add them. That's one of your factors. The other factor has an x squared and a 9 squared, and in the middle it has minus x times 9. And that's just an easy way to factor a sum of cubes. Now go back to the question. Using solution C from example 1, that's basically what they did. As a model, determine the factors. So what are the factors of x cubed plus b cubed? They are x plus b and x squared minus bx plus b cubed. All right, number 2, factor each of the following expressions. So x cubed minus 64. This is not a sum of cubes. This time we have a difference of cubes. And so the difference is, instead of a plus b, you're going to have a minus b here. And instead of a minus ab in the middle, you're going to have a plus ab in the middle. These two squareds are the same. A squared and b squared are the same. All right, so in this case, we just have... All right, so we do have to actually look to see that 64, we have to know that that's a perfect cube as well. And sure enough, 64 is equal to 4 cubed. Now, if 64 wasn't a perfect cube, like let's say they'd use 68 or something like that, well, we could still use this method, but instead of 4, we would have to say the third root of 68. So it would be a little bit uglier, but not a big deal. Anyway, luckily we do have these perfect cubes. 64 really is a perfect cube, 4 cubed. And so we just follow the difference of cubes. So a minus b will be x minus 4. A squared is x squared, plus ab is x times 4, or 4x, and b squared is 4 squared, so 16. And that is factored. X minus 4 times x squared plus 4x plus 16. It's as simple as that. All right, part B, same thing, but we have x cubed minus 125. Well, guess what? 125 is also a perfect cube. That is 5 cubed. So we can say x cubed minus 125 is just equal to x minus 5 times x squared plus 5x plus 25. 25, of course, being your 5 squared. All right, part C, now we have x cubed, which is obviously x times x times x, a perfect cube, and 8, which is 2 times 2 times 2, perfect cube. This time it's not the difference of cubes, this time it's the sum of cubes. That's all right, just use this one right here. And so you have, so x cubed plus 8 is now equal to x plus 2, the minus becomes a plus, times x squared minus 2x, the plus became a minus, plus 4, which is 2 squared. So again, this is 2 squared, this is x squared, and this is x times 2, minus here. Now, so I just have to make a comment here. Like, we have two different equations for whether it's a sum of cubes or the difference of cubes. But honestly, a difference of cubes is just the sum of the negative of the cube, right? So we can say this is x cubed minus 5 cubed, but we could also say it's x cubed plus negative 5 cubed. So it's actually the sum of cubes, but this 5 would be a negative. And then you would just use the sum of cubes, but instead of the plus 5, it would be plus negative 5, so minus 5. And instead of minus 5x, it would be minus negative 5x, so it would look like a plus 5x. But negative 5 squared is just 25, whether it's plus 5 or minus 5, and x squared, doesn't matter if it's plus or minus, they're both going to be x squared, because when you square something, it ends up positive. So honestly, this is not really two different equations. If you memorize one of them, then you could use it for all of these difference and sum of cubes. Just have to stay consistent. Like if you memorize the one with the sum of cubes, then just remember that when you have a difference of cubes, that's just plus negative 3 cubed here. Anyway, so let's just continue along. We'll just use both of the equations. And if you want to modify it to just memorize one of the two, go for it. Heck, you don't even have to memorize any of them, because you could just go back to our old ways of finding a number that makes it 0 and then factoring everything out. This is just a quick way of doing things. All right, let's go to part D. 8x cubed, which is 2x times 2x times 2x, so it's a perfect cube, minus 27, which is, well, negative 3 times negative 3 times negative 3, or you could just say it's minus 3 times 3 times 3. So perfect cube perfect cube. This is a difference of cubes. And so we have simply 8x cubed minus 27 equals 2x minus 3 times 4x squared plus 6x plus 9. If that seems complicated to you, we did the exact same thing. We did 8x cubed minus 27. That's just 2x cubed, so 2x times 2x times 2x, minus 3 cubed, so 3 times 3 times 3. So 2x times 2x times 2x is a perfect cube, 8x cubed. 3 times 3 times 3 is 27. It's the difference of cubes. And when we have a difference of cubes, we know we do the first one minus the second one. So we got to do 2x minus 3. There it is. And then you do the first one squared. So 2x squared. Well, 2x times 2x is 4x squared without the brackets. Plus a times b. So 2x times 3 is 6x. There you go. 2x times 3 is 6x, plus b squared. Well, b is 3, so 3 squared is 9. And so this is our answer. And this, if you want to write this line first, and then kind of go to that answer in your second shot, then all the power to you. Let's try part E. Same exact routine. So what cubed gives this? Well, 4x times 4x times 4x gives you 64x cubed. 5 times 5 times 5 gives you 125. If you go on your calculator, you just take the third root of 64 and you'll see that it equals 4. Take the third root of 125, it equals 5. So it's really easy to find. Just take the third root of these numbers. All right, so 64x cubed minus 125 is 4x minus 5 times 16x squared plus 20x plus 25. Hopefully, very soon, if not already, this just comes out naturally. But if you want to do it this way, you got 4x cubed, which is 64x cubed, minus 5 cubed, which is 125. So if you want to write that first, then you'll be able to keep it in your mind a little bit better, that it's 4x cubed and 5 cubed. Then you can do 4x minus 5, which is just that minus that. This 4x has to be squared, and this 5 has to be squared, and in the middle you just multiply 4x and 5. Because it's a difference of cubes, the minus goes here and the plus goes here. If it were the sum of cubes, well, then this would end up being a plus and that would be a minus. Everything else stays the same. Part F, x cubed, well, that's easy. That's just x times x times x. 1, well, that's just 1 times 1 times 1. Sum of cubes. That seems pretty easy. You've got x plus 1, x squared minus x plus 1. Right? You got your x cubed and your 1 cubed. You put your x there, your 1 there, x squared, 1 squared, and then x times 1. Because it's a sum, because the sum of cubes, this plus goes here, and the minus goes here. Done. Let's do G. All the same stuff. Take your calculator and put the third root of 27. You'll see that it's 3. The third root of 8 is 2. So this is 3x times 3x times 3x. Gives you that, and 2 times 2 times 2 gives you that. So this is indeed a sum of cubes. You got your 3x and your 2, your 3x squared and your 2 squared, and your 3x times 2 plus, because this is a sum of cubes, the plus goes in the first spot, and the minus goes in that middle spot there. And we're done. So 3x plus 2 times 9x squared minus 6x plus 4, right? Because 2 squared is 4. 3x squared is 3x times 3x, which is 9x squared once you take the brackets out. And 3x times 2 is 6x. Pretty simple. All right, I really don't know how else to say this. 729, you take the third root on your calculator, you find out that it's 9. 1,000, take the third root, you find out that it's 10. So you got your 10x cubed. 10x in brackets cubed is 1,000x cubed. 9 in brackets cubed is 729. So you got your 10x and your 9. You got your 10x squared and your 9 squared, and you got your 10x times 9. Plus goes in the first one, minus goes in the second because it's a sum. See, when you have the sum, you got the plus in the first, minus goes in the middle here. When you have the difference, the minus goes in the first, and the plus goes in the middle there. And yeah, one left to do. 216x cubed minus 8. All right, so 216x cubed. Of course, you put 216 in your calculator, take the third root, you get 6. So it's 6x cubed. And the third root of 8 is 2. So you get your 6, 8 and your 2, or sorry, 6x and your 2. Now you get your 6x and your 2 here, your 6x, your 2, those are both squared. 6x times 2 goes here, and you end up with 6x minus 2 times 36x squared plus 12x plus 4. 12x, 36x squared, 4. Well, I'm really hoping that you guys by now have figured this out, but here's number 3. Might as well do it. So we got 64x cubed. I'm going to take the cube root of 64. I get 4. 27y to the 3. Cube root of 27 is 3. So this is 4x times 4x times 4x. This is 3y times 3y times 3y. So let's modify our equations. All right, I know this is ridiculously easy. So 4x times 4x times 4x is your 64x cubed. 3y times 3y times 3y is your 27y cubed. And so you just have to say 4x plus 3y, and then you got your 4x squared, and you got your 3y squared, and you got your 4x times 3y. The plus goes here, and the minus goes there because it's a sum of cubes. And let's see, so 4x squared is 16x squared. So 4x in brackets squared is 16x squared with no brackets because the 4 gets multiplied by itself as well. 4x times 3y is 12xy. And 3y in brackets squared is 3 times y times 3 times y, 9y squared. Done. Part B, negative 3x to the power 4 plus 24x. Well, obviously we like to take out a common factor first. So let's take out a negative 3x. Right? If you look at any factoring thing that I've given you guys, the first thing you always want to do is take out a common factor. Negative 3x comes out, and oh, would you look at that? X cubed, that's x times x times x. 8 is 2 times 2 times 2. We have ourselves a difference of cubes. So let's just factor the second part. All right. This is x cubed and 2 cubed. Oh, it's the sum. Hold on. There we go. It's the difference of cubes. So x cubed minus 2 cubed. And so you got your x and your 2. You got your x squared, your 2 squared, and then your x times 2. The minus goes here. The plus goes here. So x minus 2, x squared, plus 2x, plus 4. And that means that the negative 3x to the 4 plus 24x is equal to negative 3x as one of your factors, x minus 2 as another factor, and x squared plus 2x plus 4 as another factor. By the way, you guys should know that this guy doesn't factor any further because there are no zeros. There's no x value that you can make that you can do that'll make this equal to 0. If you were to graph y equals this, it would just be a parabola that never touches the x-axis, right? So I guess I should say if you were to graph this whole thing, this negative 3x to the 4 plus 24x, we would know that the end behavior, it's going to go down to the right. We would know it's a quartic. The shape will be a quartic. We would know it would go through at x equals 0. So the y-intercept would just be 0. And it would also go through 0 at x equals 2. And we know that the end behavior, because this is a quartic, will be the same on the left and the right. So it would end down and start down. So this is actually quite an easy thing to graph now that we know how to factor. Part C, well, it doesn't get much easier than that. They literally show you what is being cubed for both of them. This is x plus 5 cubed and 2x plus 1 cubed. All right, so let's throw it in our formula. All right, to set it up, we've got our x plus 5 cubed and our 2x plus 1 cubed. It is a difference, so we're going to do a minus here. So you got your x plus 5 minus 2x plus 1. Now that makes this a plus. You got your x plus 5 squared here, your 2x plus 1 squared here, and then your x plus 5 times 2x plus 1 here. Just be careful of your rules here. We got this x plus 5 minus 2x plus 1. Well, since this is in brackets, we're going to have to do x plus 5 minus 2x minus 1. So that's going to end up being negative x plus 4. Or we could actually take this negative out, and you could say negative x minus 4. You know, it's just, we like to have x's here, not minus x's, right? So you could just pull out a negative 1 and put it on the outside. Just make sure you also make this plus 4 into a minus 4. All right, the next thing, we got x plus 5 squared, so that's going to be x squared plus 10x plus 25. Now you got x plus 5 times 2x plus 1. So 2x squared plus 11x plus 5. And then we got the 2x plus 1 squared, which will give us 4x squared plus 4x plus 1. Now you got to put all this stuff together. We have an x squared, a 2x squared, and a 4x squared. I guess that gives you 7x squared. Got a 10x, an 11x, that's 21. 25x, you got a 25, 5, that's 30, and 31. And as usual, this does not factor. This 25 times 25 is going to be less than 4 times 7 times 31. 4 times 7 is 28. 31, both of those are bigger than 25. So if you guys remember, if b squared minus 4ac is negative, then you know this is not going to factor. And so these are your two factors, and you only have one zero here when x is 4. There will be no zeros here because it doesn't factor. Your leading coefficient is negative, so you know the end behavior will be down. The degree is 3, and you know that because the degree of this part is 2 and the degree of this is 1. So your end behavior on the other side is going to go on, and it's going to be up high. Now keep in mind, I am saying that if I am talking about graphing this when there's no y variable, I'd have to say if I let y equal this, or if I let y equal this, these are the same thing, then I could graph it and those behaviors would happen. Just keep that in mind. I'd have to say let y equals x plus 5 cubed minus 2x plus 1 cubed, and then I could graph it, and I know my end behavior to the right will be negative, to the left will be positive. I'll have a 0 at 4 and nothing else really to worry about. Just the fact that it's going to go down, up, down. All right, let's do part D. X to the 6 plus 64. Well, x to the 6, that's easy. That's x squared times x squared times x squared. So that's just x squared to the power of 3. 64 is just 4 times 4 times 4. Just take the third root of 64, you'll see that. And so we just have a sum of cubes. We can just fill in the x squared, the 4, the x squared squared, the 4 squared, and the x squared times 4. All right, so your x squared squared is just x to the 4. Your x squared times 4 is 4x squared. You got minus that, and you got your 4 squared, which is 16. X squared plus 4 actually doesn't factor from there. You can't put any x value in that's going to make this negative 4, because an x squared will keep it positive. Same here, this one won't factor any farther. So this is a 6th degree polynomial right here. This one's 2 and this one's 4. But it has no zeros whatsoever, right? The end behavior is positive, so it's going to end high. And it's going to do its thing, but it'll go back high, but it'll never actually cross the x-axis. And we can see that x to the power of 6 plus 64. Well, this x to the power of 6 can never equal negative 64. You can't have a power of 6 that's going to equal a negative number. So there's no way that this is going to equal 0, because you'd have to have negative 64 plus 64. All right. The shape of this one actually kind of looks parabolish, but the second differences are not equal, so it's definitely not a parabola. The 6th differences will be equal because it's a 6th degree polynomial. All right, I don't think it's worthwhile to go over every single one of these, A, B, C, D, E, F, G, H, I. They're all very straightforward. Like this 343 is 7 cubed. This is 3 cubed. This is what, 11 cubed. You've got 12 cubed. You've got 10 cubed. They're all perfect cubes. So there's nothing different that I can teach you from here. There's 8 cubed, 5 cubed. So I'm going to go to number 5. And you, of course, can just use this as practice here. And actually, it's good for me because if I want you to prove yourself to me, I'll just give you one of these questions. All right, again here, there's nothing new. Like 1 over 27 x cubed, well, that's just 1/3 x times 1/3 x times 1/3 x. 8 over 125 is just 2/5, 2/5, 2/5. B might seem a little bit tricky, I guess, but it has a common factor of like negative 16x squared. So once you take out a negative 16x squared, then you're going to be left with a perfect, like a sum of cubes. That shouldn't be a problem. Let's see here, sum of cubes, we've already done one very similar to that. Just follow what I did. 1 over 512 to the power of 9, well that's just 1/8 x cubed times 1/8 x cubed times 1/8 x cubed, and 512 is just 8 times 8 times 8. So really the same stuff, just finding what that cube root of each term is and just throwing it into your equation. So again, I'm not going to do this. If you need a specific question answered for you because you're failing at it, then let me know and I could do it for you personally. All right, number 6 I could do. It's a little bit of a word problem. Jared claims that the expression that is equivalent to 1. Do I agree or disagree with Jared? Justify my decision. Well, let's just see. This is just a difference of, or sorry, a sum of cubes. So a cubed plus b cubed. And this is a difference, so a cubed minus b cubed. Well, it looks like this b cubed and this b cubed will cancel out. And so you get 2a cubed. 2a cubed over 2a cubed normally would equal 1. I don't exactly agree. What if a is 0? That's the one situation where that won't equal 1. So as long as a doesn't equal 0, I would agree that this is equal to 1. Jared just has to put his restrictions on. So yeah, Jared, you're kind of right. I'd give you part marks, but I'd say not necessarily. Just make sure that a doesn't equal 0, and you're good to go. All right, number 7 looks like a fun problem. 1729 is an interesting number. It's the smallest whole number that can be expressed as a sum of two cubes in two different ways. You can say 1 cubed plus 12 cubed and 9 cubed plus 10 cubed. Use a factorization for the sum of cubes to verify that these sums are equal. All right, well, let's just do it. All right, I'm not loving these questions so much. I mean, I factored it properly. You got your 9 cubed, you got your 10 cubed. So you put your 9 and your 10 here. 1 cubed and 12 cubed, you put your 1 and your 12. 1 squared, 12 squared, 9 squared, 10 squared here, and then 9 times 10 and 1 times 12. And it gave me this one 13 times 133, 19 times 91. Well, it's not really that obvious. I mean, they both equal 1729. I guess to make it a bit more obvious, you can see that 91 is just 7 times 13, and 133 is just 7 times 19. And now we can see that, 19 times 7 times 13 is obviously 13 times 7 times 19. So indeed, they are both equal. All right, this one doesn't look very fun. You need to prove that this big thing is equal to this small thing using the factorization for the sum of cubes. All right, let's see what I can figure out here. So I see that this is x squared plus y squared, x to the 4 minus x squared y squared plus y to the 4. Well, that is just the sum of cubes if the first one is x squared and the second one's y squared, right? So this is like our x squared plus y squared times x squared squared, which is x to the 4, minus x squared y squared plus y squared squared. So I'm just going to replace this with x squared to the cubed plus y squared cubed. So x to the 6 plus y to the 6 is all this. All right, after replacing x squared plus y squared times all this with x to the 6 plus y to the 6, I notice something weird. Now, when I combine the x to the 6 plus y to the 6 with this next one, it's this again, except now the a is x to the 6 and the b is y to the 6 instead of before where the a was x squared and the y was y and the b was y squared. Right? So now I can replace this whole thing. So we got x to the 6 plus y to the 6, which is your a and b. You got x to the 6 squared, which is x to the 12, minus a times b, x to the 6 y to the 6, plus b squared, which is y to the 12. This all equals a to the 3, b to the 3. So since a is x to the 6, so x to the 6 to the 3. So it's actually x to the 18 plus y to the 18. All of this is x to the 18 plus y to the 18. Now if we just look at x to the 9 plus y to the 9 squared, that's just x to the 9 plus y to the 9 times x to the 9 plus y to the 9, and we expand that, we'll see we get x to the power of 18 plus x to the 9 y to the 9 plus x to the 9 y to the 9 again plus y to the power of 18. And you put those together. And thankfully we get x to the 18 plus 2x to the 9 y to the 9 plus y to the 18, which is the same as x to the 18 plus 2x to the 9 y to the 9 plus y to the 18. So indeed they are the same. Number 9. Some students might argue that if you know how to factor a sum of cubes, then you do not need to know how to factor a difference of cubes. Explain why you agree or disagree. Actually, earlier on I actually talked about that in this video. I totally agree with you. If you just know how to do the sum of cubes, then you could easily just do the sum of cubes with a negative number. For example here, let's say I know how to do x cubed plus a perfect cube. This is 5 cubed. But I never learned how to do x cubed minus that perfect cube. Well, I could just rewrite x cubed minus 5 cubed as x cubed plus negative 5 cubed, because this is just negative 5 times negative 5 times negative 5. And so I could just do it as a sum of cubes where the cubed root of this one is x and the cubed root of this one is just negative 5, just doing it with a negative 5. Right, so the sum of cubes here is x plus the third root of this, which is 5, times, well, x squared minus x times the third root of this, which is 5, plus 5 squared, which is 25. Well, I could do the same thing over here. X cubed plus the negative 5 cubed is just going to be x plus negative 5, or you can just write x minus 5, times x squared minus x times negative 5. Well, that's going to be negative 5x. Well, minus negative 5x will just be plus 5x. And then x, and then you got your negative 5 squared, which is just 5 squared. Negative 5 squared is just 25. So you actually could do it as a sum of cubes and not worry about the difference of cubes. So here I completely agree that you just have to learn the sum of cubes and you're good to go for the difference of cubes. And if you notice, it's just this plus becomes this minus and this minus becomes a plus. That's the only difference between the sum of cubes and the difference of cubes. Alright, we're done all the work here. This is kind of an interesting little thing. The number 1729, we've already mentioned that earlier in the homework from question 7. It's called the taxi cab number. Alright, so we're going to look at the internet, and the internet says, I've heard this story before. I thought it was quite interesting. So it's a conversation that happened between G.H. Hardy, who went and visited one of the best mathematical minds of our time. His name Ramanujan. He was like this amazing guy who just was incredible at math even before being schooled. Like he just kind of learned on his own. But G.H. Hardy says, I remember once going to see him when he was lying ill at Putney. I had ridden in taxicab number 1729 and remarked that the number seemed to be a rather dull one, and I had hoped it was not an unfavorable omen. No, he said, it is a very interesting number. It is the smallest number expressible as the sum of two positive cubes in two different ways. All right, so it became the taxicab number because apparently this guy's taxicab was 1729, and he didn't find anything particularly cool about it, but then he went and visited this Ramanujan dude, and he's like, no, that's a great number because it's the lowest number that can be expressed as two positive cubes. And we saw that earlier on in question number 7. Are there other taxicab numbers? Well, yeah, the other taxicab numbers would be like the number 2 is a taxicab number. because 2 can be written as 1 cubed plus 1 cubed, and it's the lowest number that could be expressed as 2 cubes, right? 1729 is the next taxicab number because it's the lowest number that could be expressed as 2 cubes in 2 different ways. But then you've got other things like, let's see, what's this number? It's 319, so 87,539,319. That could be expressed as 2 cubes added together in 3 different ways. And then you got another one that's 4 different ways, 5 different ways, and 6 different ways. So no, this is not the only taxicab number.